Welcome user, my name is Anish Yadav and I am working at MATLAB Helper. This video will show you how the gradient descent method works inside through. We use the gradient descent approach for optimization, which is highly common approach. The steepest descent algorithm is also known as a gradient descent algorithm. In this video, my goal is to help you understand the gradient descent, the purpose of cost function, an explanation of gradient descent, how to set the learning parameters, and the impact of overshooting in gradient descent will all be quickly understood. So let us begin. Before going to start actual concept, let us discuss one practical case. Suppose we are at the top of the mountain and we are asked to reach lowest point of the mountain with blindfolded approach, observing the ground and determining whether the land declines is the most effective method. Take a step down from there and repeat until you reach the lowest place. The gradient descent algorithm will take a similar approach. Gradient descent is an iterative optimization algorithm for finding the local minima of the function. It executes two phases iteratively to attain the goals. The first step is calculating the function's gradient, that is first order derivative at that point. In the next step, we are taking steps in the opposite direction of the gradient, increasing the slope by alpha times the gradient at that point from the current position. Now the question is what is alpha and how we are following this approach. At the same time, we may have question why we are considering minimum point, also called as a global minima. If we are able to find out global minima, we are getting optimized solution of the problem. Optimized solution has minimum cost function. But what is the cost function and how we can get optimized cost function and in which scenario we are considering cost function. Generally we find out minimum cost function to get best fit of line. The goal of regression problem is to find out best fitted line to available data. Before going to start actual discussion, let us talk about regression analysis. In regression analysis, we find out best fit of line for the available data to get prediction. Right here you can see the approach. In school days, we have solved this problem by using line equation, where we have to find out unknown value. Right here, y is dependent variable and x is independent variable. If we convert above problem in term of equation of line, we are able to calculate salary of that person. In the equation, age is x, coefficient value and intercept value is also known to us. Now consider updated data and the question is how we can calculate salary of the age 32. So here we are having three unknown values. If we can calculate value of coefficient and value of intercept, we get our solution. Over here you can see mathematical formulas of coefficient and intercept. But how we can confirm these are the optimal values for our data? To understand clearly, let us consider some data which is already plotted in the 2D graph. Now the goal is find out linear line which is best fitted line for available data. But you might have so many lines. Now, how we can choose optimal one? Let us assume one random line, calculate error, sum all errors and divide the value by number of data points. The result is mean squared error, also called as the cost function. Now y predicted we can replace by equation of line. Now calculate cost function for all random lines. The line which shows minimum cost function is best fitted line for the given dataset. By calculating cost function for random lines is not efficient approach. It is very difficult job. Also, if we plot cost function versus rotation of line, we will get this type of graph. And the point which is noted is optimal value and represent minimum cost function. If we look the respective rotation of line, this line will represent best fit of available data. So this is how we can find out global minimum point of the function. But what we have discussed was graphical approach. In the real world, it is not so easy to get global minimum point of the function. So do we have any other approach? Yes, we do have. Gradient descent is the algorithm that helps us to find out best fit of line in very efficient way. Let us discuss shown diagram. This is how curve will look if we consider 3D approach. In the plot, I have plotted mean squared error against M and C. Now to get global minima, we have to start from any random value. In the next step, reduce the values of M and B by some amount. Repeat the steps until we reach global minima of the graph. In the approach to get minimum point, we have taken many steps. But how we can take those many steps? We can resolve this 3D graph into 2D graph. For sake of simplicity, take any graph for the analysis. Now in the graph, I have taken fixed step to get minimum point, but unfortunately I missed global minimum point, and in this case my gradient descent is never converge. This problem is called as an overshooting in gradient descent. Let us discuss one more approach. In this case I am following the curvature of my chart, and also step size is reduced when I reach the global minimum point. If I achieve something like this, I can get global minima. To follow this approach, I have to follow certain steps. For example, consider one point. To get that point, I need slope of that point. Slope at that point also denotes in which direction I have to take steps. Actually, learning rate along with slope we are considering to get next point. Here, slope is nothing but partial derivative of b with respect to cost function. I have mentioned partial derivative because cost function is dependent on two unknown variables. Right here you can see equation of cost function. Partial derivative with m and partial derivative with b. Then once we have partial derivative, by knowing steps also called as a learning rate, we are able to find out our best values of m and b. Here you can see to calculate updated values of m and b, we need to subtract slope in conjunction with learning rate from old values of m and b respectively. For example, suppose at this point we have b0. To get b1, I need to subtract partial derivative of b in conjunction with learning rate from b0. This is all about the theoretical approach. Now let us implement gradient descent algorithm in the MATLAB. The code is started with initial commands. Sims of x will create symbolic function, and I have considered one random equation for analysis. The variable df has stored derivative of the function f. Now if we plot differential equation, we will get this type of curve. Now our goal is to find out global minima of this curve. Number of iteration and learning rate will help us to find out global minima of this function. Now let us run the second section for 120 iteration and 0.001 learning rate. Now run the code. Now look carefully what happened here. We have chosen very low value of learning rate. For this learning rate, our algorithm has not converged to global minima. Now what we can do? Should we increase iteration? But increasing iteration is not appropriate approach. Our function is dependent only on one parameter. F x0 has calculated function value for respective x value. In this approach, we have started with 12 as a random guess. So for 12, we got 110 as a function value. That's why in the graph, our algorithm has started from 12 and 110. After that, code has iterated and updated the values of x and y, where x is one parameter value and y is a function value. But for mentioned iteration and learning rate, we have not converged to global minima. Let us increase the learning rate to 1 and run the code. What happened here? This problem is called as an overshooting problem in gradient descent. Now we can conclude learning rate is much important to converge our function to global minima. Learning rate would not be very high and also it would not be very less. So if we change learning rate to 0.1, our function is converged to global minima. So we can conclude from this analysis, gradient descent is optimization algorithm which we can use to find out global minima of the function. Values of iteration and learning rate is important to get minimum value of the function. In machine learning and deep learning, we use gradient descent to get optimum values. This will end our video. In this video, we have seen internal working of gradient descent. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our feature. Happy MATLABing.